All right, so for tonight's home play is basically the introduction to simplifying rational expressions. So you're going to see that today. So it's only 5 problems, very simple. But let's start with a warm up really quick, and I'll continue with the lesson. So get a blank sheet of paper out, title it Rational Expressions. Rational Expressions. Here is the objective, please. Nate, go. On three. 1, 2, 3. All right, and everybody say, hi, Algebra 2. Let's go. Paulina, can you get the left light, please? So, in the past, guys, before we got to Common Core, this concept of rational expressions was part of Algebra 1. But since they reconfigured some of the standards, they sent some of the standards from geometry and statistics into Algebra 1. So that's why now this is part of Algebra 2, this concept that you're about to see today. And this will be probably the last concept we're going to go over in the school year. And of course, we have a pop party. Let's go. Everybody say thank you, Jerry, for Presidente.
Thank you, Jerry.
So yeah, rational expressions. Before I get started, though, really quick, one thing that we're going to be looking at is to simplify. But there's going to be a second thing that they're going to ask us to do, which is to find the excluded value. What does that mean? We're going to look for a value that we will not use in a solution or a simplification of an expression. You're saying, I don't understand what you're saying, Mr. Kidd. Well, let me refresh your memory. At the beginning of the school year, who remembers we started with real numbers, right? And we dealt with real numbers and all that. But then I said, okay, guys, don't get scared. I'm going to show you a formula, which is with all variables, and it's all algebra. And I flashed you something like this. You guys remember that? Vaguely, yes. And I said, this is the definition of fractions. So the letter Q stands for quotient. What is quotient? The result of a division. What are fractions? Division, is that correct? That's why this is the definition of all fractions. So it reads like this. Q, even though it's for quotient, it stands for rational. Rational numbers are the set of all fractions. Is this a fraction right here? Of all fractions of n over n, where m is an integer and n is an integer. What are integers? All whole numbers and their opposites, yes? However, notice here it says towards the end, even though you can't really see it on the screen, let me highlight this one. N cannot equal to 0. Where's n? In the denominator. So what does that mean? The denominator cannot equal to 0. Why is that? Who remembers when we covered slopes that there was positive slopes, negative slopes, 0 slopes, and then there was this one that was what? Undefined, because the denominator was 0. That's undefined. That's why we cannot have the denominator equal to 0. And some of you are looking at me like, Mr. Q, I don't know. So anyways, so this is the definition. Today we're going to be looking at two things: excluded value, and then also simplifying rational expressions. So to get us started, what are rational expressions? Let me show you a rational expression. Okay. Now let me show you really quick what excluded value means. Pay attention, please. Don't copy this. Here it goes. Look up to the screen. Ready? Question. In order for this to be true, what values can I substitute into x? Talk it over your neighbors, please. What values can I substitute into x? Okay. Nate, what can I substitute? Okay. Kelsey, help them out. What values can we substitute? Close. Check this out. Can I substitute negative numbers? Yes, we will have a negative fraction, but yes. That is correct. We can substitute all real numbers. Paulina, man, from the corner. We can substitute any real number. That is correct. All negatives, this will end up a negative fraction. All positives, yes, we will end up with a positive fraction. However, which is the only number we cannot substitute in there? 0, because the denominator cannot be 0, so we would show it like this. X cannot be 0. 0 is what we call what? The excluded value. Kind of, sort of, yes? All right, we're going to do some more practice in a little bit. I just wanted to show really quick what it's going to look like. All right. Rational expressions. It says, algebraic expressions whose numerator and denominator are polynomials. Examples and non-examples. Copy that, please. I'll give you some time. Ready, go. All right, it says, rational expressions. Algebraic expressions whose numerator and denominator are polynomials. So first of all, according to the definition, they're algebraic expressions. They have a numerator and denominator, which means they are what? Fractions. Okay. However, that both are polynomials. So let me start with this first one right here. Let's see if it's true. This number right here, is this a polynomial? Yes. What's the degree? It doesn't have a variable, so it's 0 degree. That means it's a constant. How many terms does this have? 1. So it's a monomial. So this is a constant monomial. That is correct. What is the degree for this one? 1, which makes it a what? Linear. How many terms? 2, so it's a linear binomial. This one is also a linear binomial. Look at this one. What is the highest degree? 2, which makes it a what? Quadratic. How many terms? 2, so it's a binomial, so it's a quadratic binomial. Look at this one. Quadratic what? Trinomial. So all these are polynomials. Yes, you agree with that? All right. Look at the non-examples, though. Let me move this a little bit. Oh, really? Look at all these. If these are rational expressions, according to the definition, why are these not rational expressions? Talk it over with your neighbor, please. Why are these not rational expressions? Okay, let's see. Let's start with this one. Melanie, why is this one not a rational expression? It has an equal sign, which makes it a what, everyone? An equation. What are we looking at? Expressions. Okay. Pass someone? Nate, look at this one. Why is this one not a rational expression? Because it doesn't have a denominator or numerator or something like that. But what if we write it over 1? Then it is 1, but except for all these are greater than 1. All right. Pass someone for this one? It's an equation. All right. So hashtags. What makes rational expressions? Who can start us off? Let's see. Chris, go. No equal sign. Continue. Kyrie, What other? Hashtag what? Numerator and denominator. Numerator and denominator. Danny, hashtag what? Algebraic expression. And one last one. And it's the one that's not going to leave you forever. Let's see. Ian. Polynomials. That is correct. Next year you're going to be walking to the school, stopping by a donut, getting an iced tea, and all of a sudden from the corner in the alley, you turn. Polynomials. They're not leaving anymore. Anyways, what? Anyways, underneath that, I want you to write steps. And you're coming up with those steps. Just pay attention to the lesson. Yes? All right. Example 1A. Copy that, please. Find any excluded values of each rational expression. All right. So it says, find any excluded values of each rational expression. So, what did we say according to the definition I showed you guys? That the denominator cannot be equal to what? It cannot be 0, right? So watch. That means this cannot look like this. Look up, please. Is that correct? It cannot look like this. Which means we need to find out what number would make this what? What number would make it what? 0. You're saying, wait a minute, aren't we supposed to exclude it? Yeah, but we need to know which one it is, right? So check this out. To find the excluded value, I'm going to do the work over here. I just focus on the denominator. I grab that, g plus 4, and I equal that to 0. And all I have to do is solve. Let's see. What do I do here? Minus 4 minus 4. G equals negative 4. What does that mean? That my excluded value is 4. Let's see if it works. Let's see if it's true. I'm sorry, negative 4. Let's see. So instead of G, what am I going to substitute? What is negative 4 plus 4? And what did we say? We cannot have that. Therefore, what's our excluded value? Negative. We cannot use negative 4. Does everyone understand what we're doing? Now check this out. What does that mean? Well, that means that we can use other values. So look what I'm going to write. For all G's, G could equal to what numbers? Everyone. All real numbers. That is correct. Except which one did we just find out? So we write G cannot equal to negative 4. Copy that, please. We good? All right. Example, that was 1A. Let's go to 1B. All right. Example 1B. You don't have to copy the instructions anymore. You already have them. Just copy the expression. 2x plus 1 over x squared minus 15x. I'm going to zoom in. All right. So, to find the excluded value, what do? We take the denominator, which is what? x squared minus 15x, and we need to equal that to what? 0. That is correct. Oh, Maria, bam. So, first things first, let's check for GCF. Is there a GCF here? Everyone? X, that is correct. And we're left with x minus 15 equal to 0. Now we have two factors. What is my next step from there? ZPP, yeah, you know me. So we have x equal to 0, x minus 15 equal to 0. Let's solve. This one's already solved. I'll leave that alone. But this one I need to add 15 to each side. Therefore, x equals 15. So this one has how many excluded values? 2, these two. So let's write what are the possible values that we can use for x. The possible values are set of all x's such that x equals to what, everyone? Any real number except x cannot equal to 0 or 15. That is correct. How are we doing? All right. Example 1C. Example 1C. Copy that. Y minus 2 over y squared plus 5y plus 4. I'll zoom in. Excluded value. Tell me what to write, please. Jerry.
So y squared plus 5y plus 4.
That is correct. Everybody there so far? Yeah, because it has to be equal to 0. Do we know how to solve these kinds? Yes. What do you do from there? Factor, da, 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 da. So this is 4, this is 5. What are my factors of 4 that add up to 5? 4 and 1. You guys want to do the grouping or want to use a shortcut? So this becomes what? Y times y. And what did we get? 4 and 1. Yes? What do we do from there? ZPP, yeah, you know me. Y plus 1 equal to 0. Y, oh, this was 4, I'm sorry. This was 4. Y plus 4 equal to 0, and y plus 1 equal to 0. So minus 4 minus 4, y equals negative 4, minus 1 minus 1, y equals negative 1. So what are my excluded values? Negative 4, negative 1. And how would we write that? The solution set of all y such that y is equal to what? Any real number except y cannot equal to negative 4 and negative 1. Now, have we been simplifying these fractions? No, we've just been using or finding the excluded value. So now we're going to simplify. Did you understand that we haven't been simplifying? We've just been finding the excluded value. The same. I guess. So guess what? The reason I'm showing you this process of excluded values is because this is what you're going to be using for Algebra 2 and pre-calculus and calculus when you get to graphing. The excluded value, they use that in graphing in order to identify something that we call the asymptotes. You're like, what does that mean, Mr. Q? Well, check this out. If I was to graph something like this, there's some invisible values, or let's say not this one, but let's say I asked you this, watch. I said, I want you to graph me a graph here, and I'm going to start from here, and then it's going to go exponentially up, but it cannot cross x equals 5. So it's going to exponentially keep going larger and going up, but would it cross 5? No. This invisible line that we just established is known as the excluded value, also known as the asymptote. It's an invisible barrier that we cannot cross. Okay? You're like, okay. All right. Let's go to simplifying. Copy this one, example 2A. For this one, I just want you to write the word simplify, and then comma, and then I want you to write excluded values, or EV. So first we're going to what? Simplify. 2r to the fourth over 14r. All right, I'm going to zoom in, writing utensils down, look up to the screen really quick. I'm going to simplify this. Look up. Whenever we have a monomial over a monomial, it's basically what we did on the warm-up. We identify the GCF. Question. What's the GCF for 2r to the fourth and 14r? Tell your neighbor, please. GCF for these two. Everyone? 2r. So that if that's the GCF, that means I can divide the numerator by the GCF and the denominator by the GCF, and that's how I can simplify to lowest terms. 2r to the fourth divided by 2r leaves us with r to the third. 14r divided by 2r leaves us with 7, and this is simplified. Copy that, please. So once again, if we have a monomial over a monomial, we divide by the GCF, okay? What number was this, 2A? Okay, let me give you 2Q. Let's do 5x to the, bless you, x to the, give me a number, 3 over 20x. Simplify that one. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. What's our GCF, everyone? 5x and 5x, and if we divide each one by 5x, we're left with x squared over 4. This is simplified. Hands if you got that. Okay, so we get the idea, right? So that's with monomials. Well, guess what? This is not going to work if we don't have monomials. Let me go to the next one. Example 2b, don't copy the instructions. You already have them. But copy 6n squared plus 3n over 2n plus 1. So check this out. When you get to these, now these, we cannot find a GCF for these two yet, which means we need to focus first on the numerator, and then we go to the denominator. So question, what is the GCF for the numerator? 3n. So we write 3n, and we're left with 2n plus 1. Does everybody see that? Okay, so we're done with this one. Let's go to the denominator. What's GCF for these two? 1, and we're left with 2n plus 1. Question. What is this over this? A giant 1, is that correct? So what does that leave us with? 3n over 1, which is 3n. And that is simplified. Yes, kind of, sort of. Okay. Once again, for monomials, you do need GCF for numerator and denominator. For binomials or anything greater, you need to factor out each individual first, and then you simplify. All right, let's move on. Example 2C. No, that's too easy. How about this one? Oh, we had it written. Oh, let's kick it up a notch, yes? Sorry. Copy this one, example 3A. and just copy this one. Start us off, please, Jaylene. What's the GCF in the numerator? 1, and we're left with x plus 2. If we factor out a GCF where the denominator is still 1 and we end up with the same thing, right? Which means we have to factor this one, don't we? So, Power Rangers, 6 and 5. Factors of 6, that add up to 5, everyone. 2 and 3, 8, 20. So, let's use a shortcut. That becomes what? X and X. And what are the two numbers that we come up with? Plus 2 and plus 3. Okay, look up, please. Look up, look up. What do we have here? What is x plus 2 over x plus 2? A 1. So what do we have left in the numerator? 1 over x plus 3. And this is simplified. Thank you. Thank you. So our home plate for tonight, basically is for the first two, you just need to find the excluded values. But for the last three, is simplifying just like we did on these last ones. Yes? All right, guys, have a good one. Enjoy your home plate. See you guys tomorrow. Bye.